Colpit oscillator. In the previous video we have discussed about Hartley oscillator, and we have also discussed in Hartley oscillator how the feedback is inductive. In this video we will discuss about Colpit oscillator, and we will discuss how the feedback in Colpit oscillator is capacitive. Long question will come like this: give the circuit diagram of Colpit oscillator, explain its action, discuss the advantages, disadvantages, and applications of a Colpit oscillator. What is a Colpit oscillator? Colpit oscillator is a sinusoidal oscillator, sinusoidal feedback oscillator. It is also a LC oscillator. So you should write Colpit oscillator is a sinusoidal feedback LC oscillator. I have discussed in the previous video about feedback oscillator or LC oscillator. You watch the previous video before watching this video. Then we will discuss about the circuit diagram of Colpit oscillator. This is the simple circuit diagram for Colpit oscillator. This is a PNP transistor, and these are resistors R1, R2, RE, CE and CB. These resistors are useful for the transistor biasing and transistor stabilization, because we need transistor biasing before of its operation. In transistor biasing and stabilization, we will specify the Q point, that is the operating point. That is why these resistors and capacitors are required. And to know about transistor biasing and transistor stabilization, you watch my previous video on biasing and stabilization. And here the tank circuit or LC circuit, this is your tank circuit or LC circuit, and to the tank circuit you give a voltage VCC. So this is the simple diagram of Colpit oscillator. And in the examination you should write about these things, that is VCC is the collector supply voltage, CB is the blocking capacitor, C is the bypass capacitor, R1, R2 are the base resistors, RE is the emitter resistor, and L1, L2 and C, they form the tank circuit or the oscillatory circuit. And I have told you these resistors R1, R2 and RE along with CE, they are used for transistor biasing, and here the biasing method is the voltage divider bias. Now we will discuss about the working in case of Colpit oscillator. As I have told you, the transistor here in case of Colpit oscillator you are using a transistor, and I have shown you the transistor is in common emitter configuration, and the common emitter configuration produces a phase shift of 180 degree between input voltage and output voltage. So look to this diagram. This is your emitter, this is your base, and this is your collector. So base, emitter, this is your input, and emitter, collector, this is your output. So when you apply signal to this input, in the output you have a signal of phase shift 180 degree, because this transistor will produce a output of phase 180 degree between input and output. And in the tank circuit you will give a potential VCC. This is your tank circuit. It consists of a inductor and two capacitors C1 and C2, and you give a potential VCC to this tank circuit. This is from the external source, as a result of which LC oscillation will start. When you give some energy to this tank circuit or oscillatory circuit, then LC oscillation will start. And for the operation of LC oscillation, you look to my previous video how in LC oscillation, the magnetic energy from this inductor will be converted into electrical energy in the capacitor, and again in the electrical energy in the capacitor will convert to magnetic energy. So this process will continue, and this is called LC oscillation. And you see here the total voltage will be divided by the two capacitors C1 and C2. Okay. So when you divide the total voltage between these two capacitors C1 and C2 which are in series, so you introduce a phase shift of 180 degree in between the two capacitors. So you have 180 degree phase shift due to this transistor, and again 180 degree phase shift due to this capacitor. And this capacitor which producing 180 degree phase shift, when added to this signal, output signal, that is 180 degree, when the two phase you mix the two phase, then the total phase shift will be equal to 360 degree or 0 degree. So when you give the feedback to this input of this transistor, the phase shift will be equal to 0 degree or 360 degree. That is why you are introducing a positive feedback, or you are giving a positive feedback to this transistor. When you give positive feedback, you will get sustained oscillation. A positive feedback will produce a sustained oscillation. Thus, in this way, the colpitts oscillator, in colpitts oscillator, the feedback is capacitive. Okay. In case of Hartley oscillator, I have explained that the feedback circuit is inductive, because they are you have center tapped the inductor, but here due to these two capacitors which are connected in series, the colpitts oscillator feedback circuit of the colpitts oscillator is capacitive. So this is the working of, you should write, this is the working of your colpitts oscillator. The transistor in common emitter configuration produces a phase shift of 180 degree between input and output voltage, and in the tank circuit you are giving a potential VCC, and the voltage given to the two capacitors C1 and C2 are equally divided because they are connected in series. Thus a phase shift of 180 degree is produced in capacitor C1. So what will be the total phase shift? Total phase shift will be 360 degree or 0 degree. So a positive feedback is produced for sustained oscillation. That is why colpitts oscillator feedback is capacitive. Then you write about frequency of oscillation. At a resonance, the reactance produced by the capacitor will be equal to the reactance produced by the inductor. Xc is equal to XL, and what is Xc? 1 by omega C. Omega is the angular frequency, C is the capacitance of the capacitor, and what is XL? That is omega L. L is the inductance of the inductor, so omega square will be equal to 1 by LC. So omega will be equal to 1 by LC square root, and omega is equal to twice pi f. Omega is the angular frequency and f is the linear frequency. The relation between angular frequency and linear frequency is omega is equal to twice pi f. So twice pi f will be equal to 1 by square root of LC. So f will be equal to 1 by twice pi square root of LC. Since the two capacitors are connected in series, so the effective capacitance 1 by C will be equal to 1 by C1 plus 1 by C2. Here C is the effective capacitance. So you can find out the effective capacitance. C is equal to C1 C2 divided by C1 plus C2. So if you put this value of C here, then you will get the frequency of oscillation in colpitts oscillator, that is equal to 1 by twice pi square root of C1 plus C2 divided by L C1 C2. This formula is very useful, and problem will come. You have to use this formula to solve the problem. So you should remember the frequency of oscillation for the colpitts oscillator. Then what are the advantages of colpitts oscillator? Colpitts oscillator have excellent frequency stability. Frequency can be varied by using both the variable capacitors. Colpitts oscillator can generate high frequency sinusoidal signals. it can be withstand high and low temperature, it can withstand high and low temperature. High, it can be used in high temperature as well as in low temperature. This is the main advantage. The amplitude of the output remains constant for a fixed frequency range. So these are the main advantages of Colpitts oscillator. Then what are the disadvantages of Colpitts oscillator? The disadvantages is the adjustment of the capacitor C1 and C2. It is very deep in practical. It is difficult to adjust the capacitance C1 and C2, and the range of variation of frequency is small. So these are the disadvantages. What are the uses of Colpitts oscillator? Colpitts oscillator are generally used in high frequency sine wave generator, and they are also used in radio receivers. In the next video, we'll discuss about a comparison between Hartley oscillator and Colpitts oscillator. Thank you.